Hello everyone, welcome to the solution of LeetCode problem 1203 named Sort Items by Group Representing Dependencies. In this problem, there are n items each belonging to 0 or one of the m groups where group of I is the group that the ith element belongs to. And if group of I is equal to -1, that means ith element does not belongs to any of the group. Now, the items and the groups are zero indexed and a group can have no item belonging to it. Now we have to return a sorted list of the item such that the item that belongs to the same group are next to each other in the sorted list, and there are some relations between these items where before items I is a list containing all the items that should come before the ith item in the sorted array to the left of the ith item. Now we have to return any solution if there are more than one solution exist. And if there are no solution exist, we have to simply return an empty list. Now let's consider the first example. Here we are given 8 items from 0 to 7, and these are the groups and these are the before array. So item number 0 does not belongs to any other group because it is -1, but item number 5 does belongs a group which is equal to 1. Item number 4 belongs a group which is equal to 0. So here we can see that as there are two elements 3 and 6, so we can say that the element 3 and 6 must become before the element 4. Similarly, the element 6 must become before the element 3. The element 5 must come before the element 2, and the element 6 must come before the element 1. So let's consider this output array where we can see that the element 3 and 6 comes before the element 4. The element 6 comes before the element 3. The element 5 comes before the element 2. And the element 6 comes before the element 1. So we can say that this output list satisfies all of the conditions. Now, I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken the same example. Now, at first we have to determine in which algorithm we should use. As this problem, we are mentioned the dependencies. Basically, if any kind of graph problem, we have to deal with the dependencies, we will use the topological sort, and to implement the topological sort, we will use the Kahn's algorithm. Now, in this problem, we are given two entities. One is item, another is group. So we have to make the graph by using the item and the group. And let's see how the topological sort works on those graphs. Now, at first, let's make the graph with the group. So here, at first, we have to see that the element 0, 1, and 7 does not belongs to any of the group. But as the element 0, 1, and 7 does not belong to any of the group, that means it can belongs an empty group. So here there are two groups at now, which is 0 and 1. So we can say that the item 0 belongs to the group 2, the item 1 belongs to the group 3, and the item 7 belongs to the group 4. So here we can see that as 0, 1, and 7 does not belongs to any of the group, so we can reassign the group 2, 3, and 4 to this 3 items. So far so good. Now let's make the graph or the dependency graph by using the group. So here for this node 0, we does not have any of the dependencies here, so we don't have to do anything. For this node 1, the dependency is 6. So what is the group of 6? The group of 6 is 0. So we have to put 0 here. Now there is a connection between 6 and 3. So what is the group of 3? It is also 0. So 0 connected to 0, this does not mean anything. So we will simply put 0 here. Now there is element 5. So what is the group of 5? It is 1. So we will put 1 here. And there is element 1. So what is the group of 1? It is 3. So 1 is connected to 3. Now for this element 6, what is the group of 6? It is 0. And for this 0, what is the group of 0? It is 2. So 0 is connected to 2. Now for this 3 and 0, what is the group of 3? It is 0. And what is the group of 0? It is 2. So there is a connection between 0 and 2. So it is already presented, so we don't have to do anything here. For this 6, what is the group? It is connected to 0. So the group of 6 is 0 and group of 0 is 2. So there is a connection between 0 and 2. It is already presented. Now we have finished all of the group, but there are 4 groups basically. So the group number 4 will stand alone. So if we apply the topological sort on this algorithm, what will be the output? In the topological sort, basically we will take the element or the node which has the integer 0. So here the node has the integer 0 is 4, 0 and 1. Because the node 4, 0 and 1 does not have any of the edge coming towards it. So here, after taking 401, we have to discard the edge between 0, 2 and 1 and 3. After that, the element 2 and 3 will have the integer of 0. So this is the sorted version of the groups by using the topological sort. Now let's make a graph by using the item. So here for the item 0, it does not have any of the dependencies. So we will simply put 0 here. For the item 1, we have the dependency 6. So 6 must come before after the element 1. Now for this 5, it has the dependency of 2. So 5 is connected to 2. That means 5 should be taken before the element 2. For this 6 and 3, 6 should be taken before 3. For this 3 and 4, 3 should be taken before 4. For this 6 and 4, 6 should be taken before 4. Now the node 5 is presented here, the node 6 is presented here, and we have to put 7 here because 7 does not have any of the dependencies. Now, what is the topological sorted version of this? We have to first put the element which has the in decrease 0. So here, the element has in decrease 0, it is 0, 6, 5 and 7. So we have to put 0, 6, 5 and 7 here. Now we have to discard all of the connection from 0, 6 and 5. Now the element has in decrease 1, in decrease 0 will be 1, 3 and 2. So we have to put 1, 3 and 2 here. Now we have to discard the connection between 3 and 4. So now the in degree 0 will have the element 4. So far we have found the topological sorted version of the groups and the topological sorted version of the items. Now let's make another vector of size, let's say 5 for each of the group. So here, for this, there would be 5 group, which is 0, 1, 2, 3, and 4. Now, 3. So we have to put 1 into the list of 3. For these 3, the group it is belongs to is 0. So we have to put 3 into the list of 0. For these 2, the group it belongs to is 1. So we have to put 1 into the, we have to put 2 into the list of 1. And finally, for this 4, the group it belongs to is 0. So we have to put 4 into the list of 0. Now we have built this matrix, and here, what are the order of the group? It is 4, 0, 1, 2, 3 into the topological manner. So we have to put the element 4 first. After that, we have to put the element in the 0. It will be 6, 3, 4. Then we have to put the element in 1. It will be 5, 2. Then we have to put the element into the 2 and 3. It will be 0 and 1. Now, this is our desired output, because if we see that the element 3 and 6 must be before the element 0. So here we can see that 3 and 6 must be before the element 0. The element 6 must be before the element 0. The element 6 must be before the element 0. The element 5 must be before the element 1. The element 5 must be before the element 1. And the element 6 must be before the element 3. So we can see that the element 6 must be before the element 3. So here, so far we have seen that this is our desired output, and we have calculated this output by using the Kahn's algorithm on the topological sort on the groups and the individual item graph. I hope you understood the algorithm. Now let's move on to the code. In this algorithm, the code is pretty simple. At first, we are given a function named sorted items, which has integer n, m, groups, and before items. Now, if any of the element group is -1, that means we have to assign the group to it and increment the m. Now, we have to take a two-dimensional vector which will store the adjacency of groups and the adjacency of items. And we will calculate the degree and store it in a vector. For the groups, the vector name is degree group. And for the items, the vector name is degree items. Now, here we are building the adjacency list for each of the groups and each of the items and incrementing the degree. So for each element in the N, the to group is group of I, and for each of the element in before items, the from group will be group of from. Now if 2 is not equal to from, we have to insert the the 2 into the adjacency list of from for the group, and we have to increment the two groups degree. After that, we have to insert the element I into the from and increment the degree of I. Now, we have to call the topological sort function on the groups and on the item by using the group degree and item degree and store the topological sorted vector into the corresponding group vector and item vector. Now, inside the topological sort, we have to take a queue and we have to take a vector to store the result. Now, for each of the element in the size, if the degree is equal to 0, we have to insert it into the queue to run the BFS. Now, in this BFS, if the queue is not empty, we have to insert or take the front element of the queue and store it in a variable named current. And we have to remove the front element of the queue and insert the front element into the result array. Now, for each of the child into the adjacency list of current, we have to decrement the in degree of the child. And if the in degree of child is equal to 0, we have to insert child into the queue. Now, if the result size is equal to the parameter size, we have to return the result array. Otherwise, we have to return an empty vector. So far, we have found two vectors. One is the sorted list of group. Another is the sorted list of item. If any of them is empty, we have to return an empty list. Otherwise, for each of the sorted item, we have to make the group item array. So here, the group items of group I, we have to insert the element I. Now, we have to make or build the answer array. So for each of the element in the group I, we have to access the group items index for each of the element and insert all of them into the answer array. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.